Hello, in this video, we're going to find a reference angle for a given angle, of course, that's what it says. And we know reference angle is when, when you have an angle in started position, like theta, theta is an angle position. The reference angle theta bar associated with that reference angle is the acute angle formed by the terminal side of theta and the x-axis. So make sure that it goes on the x-axis. So it can be either in degrees or radians. So, if you have the XYZ, so usually you're looking for the reference angle associated with the acute angle in reference with the x-axis, not the y-axis. So let's see, first of all, what 7 pi over 10 is. So the first thing you need to verify, where do you think 7 pi over 6 over 10 falls? Is it located in the first quadrant, in the second quadrant, or the third quadrant? So if you have some very hard time figuring it out, remember you have this in the previous examples that I covered. Feel free to watch the other videos so you can see, this unit circle, it's very difficult to see where 7 pi over 10 is located in this one. But you need to figure it out if it's in the first quadrant, in the second quadrant, in the third quadrant, or the fourth quadrant, because it says it's 7 pi over 10. The coefficient of pi, the numerator, the coefficient in the numerator is less than the one in the denominator. If you had like something greater than 10, then you would say, oh, you might be either in the third or the fourth quadrant, but because 7 is less than 10, so you would be either in the first quadrant or the second quadrant. So at this point, because we need to do it in reference with the x-axis, 7 is closer to 10 than closer to 1. So we would assume that for the first one right here, what we're going to do, we're going to subtract from pi. Remember, pi is on the x-axis. And so we're going to subtract because on the unit circles right here, you have 0 and you have pi and you have 2 pi. So would you subtract it from pi or would you subtract it from 2 pi? So 2 pi is pretty too far to do that. So because 7 is less than 10, so we assume it would be either in the first quadrant or the second quadrant. So we're going to subtract 7 pi over 10 from pi. So if you look for the same denominator, you can divide both sides by 10, okay? Multiply and divide by 10. So we have 10 pi minus 7 pi over 10. So the answer for the first one would be 3 pi over 10. So that would be actually the right answer for that would be the right answer for this. Let me put it here instead so you can see it. All right, so that's the correct answer for this. Now, if you want to see it, you can either convert all of this. So what is the reference angle at this point? Let's say for this one, this is, if they asked me to graph, if I was asked to graph 7 pi over 10, I would say probably 7 pi over 10 would fall somewhere here. So this is my 7 pi over 10, okay? Now remember, we said the reference angle theta associated with theta is the acute angle formed by the terminal side of theta and the x-axis. So acute angle is an angle that is less than 90 degrees. So this is the reference angle at this point. That's why we subtract it from 10. So reference angle, we're gonna call this one theta. So that's that particular, that one right here for us is the same thing saying, oh, this distance from the x-axis, 190 degrees to this one here is 3 pi over 10. So that's what you have here. Now, if you look at the second one, okay, first of all, because the numerator is greater than the denominator, but it's not twice. It's not twice, okay? So 11 over 8 pi, okay? 11 over 8, we can say 11 over 8. If it was 8 over 8, it would be exactly pi. But 11 over 8, as you see, 11 is very, very close. Well, only 3 units from 8. So we can say also here, we need to subtract again because the 11 is greater. What we can do is taking 11 pi over 8. Now, because it's greater than pi, instead of subtract it from pi, I would subtract pi from it. But because we are closer than the x-axis negative than x-axis positive, 11 pi over 8 is approximately around 245 degrees. That's all in the third quadrant. Feel free, you know how to convert, degrees, right? To radians. You can do that also if you want. Take the pi over 180. So you will see, if you don't see where it's located using radians, you can convert your radians to degrees so you can find out where it is. So let's say for this one, same denominator, we're gonna divide and multiply and divide by 8. So we end up having 11 pi minus 8 pi over 8, and the answer would be again, oh, this one is 3 pi over 8. So the answer is not that far also. So, and the first one was this one. Now, if you want to graph it again, what you're going to do, 11 pi over 8, as I said, it's located because it's greater, it's a little bit greater than pi, because if it was 8 pi over 8, it would be simply pi. Because we are pretty close, so I assume that probably 11 pi, let me change, take a different color. So 11 pi starting at 0 probably would come right here. So this is my 11 pi because probably 145 or something. So the whole thing right here is 11 pi over 8. Now, what is the reference angle? Reference angle is the acute angle. So that would be this distance. Okay. So this distance is our reference angle. So it would be, it's simply pi plus, 3 pi over 8. And we call it reference angle with a bar on top of it. So that's what we're gonna do to find this answer. Now, for 10 pi over 3, what you can see from 10 pi over 3, I realize at 10, you have three threes in 10. So now instead of subtracting, and it's really greater than pi. So we are closer to 2 pi than pi. So if we're on, because 2 pi, no, it's even bigger than 2 pi. So we're going to subtract 3 pi because even 3 pi is still smaller. So what we're gonna do, we're going to take 10 pi over 3 minus 3 pi. The reason why we do that, if it was, let's say if we had only 7 pi, for example, that would be very close, 7 pi over 3. If we had something like 5 pi over 3, we would do it, we would take it from 2 pi, but that's not the case here. So what we have from here is really 3 pi. So remember 3 pi, what's it gonna be? So, all right. So having the same denominator, let's use same denominator here. Is 3 pi, is 3 over 3. Now, is give us 10 pi minus 9 pi, same denominator is 3. Now 10 minus 9 is simply pi over 3. And this is the answer for the third one. That's the acute angle. Remember, acute angle is an angle. The one I do in blue, right? Is that the one I do in light blue? Yep, that's always the smallest one, less than 90 degrees. So, you know, we have now, as you can see, 10 pi over 3 is like 3 pi plus pi over 3, right? 3 pi plus pi over 3, that gives us 10 pi over 3. 3 pi over 3, so it's like for us, we have, we need to go three times around, right? No, 10 pi over 3 is like, it's not 3, but I think that might be 360, I mean 2 pi. You have 2 pi plus, you know, it's like 3 pi. Let's do 3 pi. This is 3 pi. Remember, one revolution is 2 pi. This is 3 pi, okay? But remember, it's 10 pi over 3. So when we had 3 pi over here, we need to add again another pi over 3. That's represented 60 degrees. So you see, this is where your angles are. So all of this is 10 pi over 3. Now, what is our reference angle? Reference angle is an acute angle, so that would be this side. Okay, so this side is our reference angle. I believe that would be a reference angle from the x-axis, you know, right here is pi over 3. So that means if you take 3 pi plus pi over 3, that's gonna give you 10 pi over 3, right? So now let's hope, you know, send 3 pi plus pi over 3 would give you 10 pi over 3. And if you want, you don't see where it is exactly located, you can still convert to degrees by using this formula. So hopefully you can use this example to do more reference angle. Remember, we said the reference angle is the angle theta bar associated with theta is the acute angle formed by the terminal side of theta and the x-axis, not the y-axis. We don't refer anything regarding to the y-axis. So we need to make sure by comparing the x-axis, we identify in which quadrant our angles is, our theta is located. Take care and don't forget to subscribe for more videos. I'll see you soon in a different video. Take care.